Hey guys, this is a tutorial video about how to classify triangles. I'm going to talk about two different ways to classify triangles. One is by using the angles in the triangle, and the second is by using the different side lengths of triangles. Hopefully a lot of this is review for you. Some of these might be new, but most of you have learned how to classify triangles already at this point. So these are the different ways we can categorize triangles by their angles: acute, equiangular, right, and obtuse. Equiangular might be a new one for you, but all that means is that all the angles in my triangle are congruent. With side lengths, we have three different classifications. Equilateral, and that word equal kind of tells you that all sides are going to be the same, so all sides are congruent. You can see that in my picture. Isosceles means at least two sides are congruent. So technically, equilateral triangles are also isosceles because they have at least two. But this is another example of isosceles where I have two congruent sides, but the third one is not. And then scalene means all my sides are different lengths. So those are the three ways to classify triangles by sides. So that's what we're going to be doing down here in these first few examples, is we're going to kind of use those few different vocabulary words as a word bank. And we are going to classify these different triangles by their angles. Okay, so that means we're going to use acute, equiangular, right, or obtuse to classify by angles. And for sides, our choices are equilateral, isosceles, or scalene. Okay, so we're looking at triangle FGH. So I've got F, G, and H. And I know that all the angles in a triangle have to add up to be 180 degrees. So 60 plus 60 plus another 60 is what would get me to that 180. So if they're all 60 degrees, that means all their angles are equal. So I can say this is equiangular. Triangle FGH by its sides. Okay, so this is another kind of important thing, that if I have an equiangular triangle, it's also going to be equilateral. So if all the angles are equal, so are all the sides. So this is actually also an equilateral triangle. Okay, EHF. EHF, so this kind of leftmost triangle, by its angles. So this angle, I know this has to be a linear pair here. So if this is 60 degrees, this angle would be 120 because it's on a line together. 120 is bigger than 90 degrees, making this an obtuse triangle. I'm also going to classify EHG, so that's the whole thing, by its angles. Well, I know this is 30, this is 60. This angle is a combination of these two. So if I use that angle addition postulate and add 30 and 60, this would give me a 90-degree angle, making it a right triangle. Okay? Now these questions 5 through 8, we're actually going to look at this note to kind of help us out. It says the largest angle of a triangle is always opposite from the biggest side, and the smallest angle is always opposite from the smallest side. So we're going to kind of use that to answer 5 and 6. Which side length is the largest in EHG? So EHG, that big one altogether. Well, my biggest angle out of the three, I had 30, 60, 90. So if this is the biggest angle, the biggest side is going to be across from that. So EG is going to be the longest side. Which side length is the smallest in that triangle? So I had 30, 60, 90, so 30 is the smallest angle, so opposite of 30 is that smallest side, making that be HG. Okay, and we're going to classify EHG by its side lengths. Well, I don't know the sides, but just by looking at it, this side and this side are obviously different, and this side is bigger than this side, because I'm not told of any isosceles markings. So if they're all different, we can say that it is a scalene triangle. Okay, we are going to use some information here to find the value of x. And actually in this problem, they kind of give us some excess information. All I really need to pay attention to is these congruency markings. So with that, that tells me that this side and this side are exactly equal. So I can go ahead and just set those equal to each other and not even worry about this last side. So I've got x plus 2.4 equals 2x plus 1.7. Okay, I'm going to get my x's together first here. So I've got 2.4, 4 equals x plus 1.7. Subtract 1.7 from each side. And let's see, we've got, I think, 0.7 left over. So 0.7 is equal to x, and that's all they were asking me to find. So again, I didn't even have to use this side as information. Alright guys, that's it for the 4.1 video. Thanks for watching.